Okay, now 2.4, we're continuing from 2.3 and talking about graphing a system of equations, two or more equations. So these first ones are just story problems. So we've got to figure out some equations and then we can graph them. It says the value of two numbers if their sum is 21 and their difference is 3. Well, let's call one number x and one number y. So their sum, when I add them together, is 21. Their difference, when I subtract them, and it doesn't matter which one we put in front to subtract, is 3. So we've got two equations here that we can graph. So if I were to subtract x and turn it into slope-intercept form, we get y equals negative x plus 21, and negative y equals negative x plus 3. Divide everything by negative 1. We get y equals positive x minus 3. So 1, 2, 3 minus 3 for this first one, and then we would slope of 1 over 1. So we'd go up 1 over 1, up 1 over 1, up 1 over 1. So we've got that pattern, right? Alright. Then for the other one, we start up at 21, which I believe is 1 up there. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that would be 20. And now it's negative x, so negative 1 over 1 for our slope, so down 1 to the right one. And we look to where they intersect, because that intersection point is going to tell us what our two numbers are. The x and the y. Okay, and we can see right there, so let's just stop right there. So, wow, that was a horrible line, but our point is right there. So it'd be that x, that y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 for x. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 for y. Which works, right? Add them together, 21. Subtract them, 3. Okay, so we can use that system to help us understand that problem. Okay, same idea over here. Okay. We take two numbers, sum is 20, so x plus y equals 20. Or if we changed it, y equals negative x plus 20, right? Because we subtract x from both sides. So we go up here to 20, and we go down 1 to the right one. Okay, pretty simple slopes here. We draw our points. My points are a little off. Just with this capacitive screen, sometimes I'm not the most accurate. I take my best guess. So we'll just leave it dot form instead of drawing a line. Okay, then we do the second one. Their difference is 6. So x minus y equals 6. So I would have to subtract x from both sides. Get negative y equals negative x plus 6. Divide by negative 1. And we get y equals positive x minus 6, right? So I go down 6. 1, 2, 3, 4, 5, 6 to start us off. And then up 1 over 1, because that's the slope. Up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Oh my goodness, having troubles. We see right where they intersect, don't we? Right at that point. And the point is that intersection. The whole reason we're doing this is that intersection. So there's my y value. 1, 2, 3, 4, 5, 6, 7. So y equals 7. So what would x equal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So x equals 13. Add them together. That's 20. Subtract them. That's 6. There's our answer. Okay. Now we could write that in the point form, coordinate 13, 7 and 12, 9. And that's what they mean. So let's take a look at some other equations. So the county fair is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 1 van and 2 buses with 56 students. High School B rented and filled 5 vans and 3 buses with 133 students. Each van and bus and each bus carry the same number of students. How many students can a van carry? How many can a bus carry? Alright, so let's set this up. Okay. So we've got high school A. They have one van, 2 buses, and they have students on those, right? And 56 students. So their total of how many they're carrying is equal to 56. And they had one van, and a van carries a certain amount of people. We'll call that X, the number of students in a van. And we'll say Y is number of students in a bus. And so we have X plus 2Y, because there's 2 buses and 1 van for 56. So if we solve this one to graph, we get 2Y equals negative X plus 56. Divide everything by 2. We get Y equals, that's like negative 1/2 X plus 56 divided by 2 is 28. Okay, now for our second, we've got 5 vans, so 5X plus 3 buses, 3Y equals 133. Subtract 5X, we get 3Y equals negative 5X plus 133. Divide everything by 3. We get Y equals negative 5/3 for our slope. And then 3 goes into 133. 3 goes into 13 4 times. 12 minus 1. So 4. And then minus 1 would be 10. So it would be 1 and that decimal. Bring down 0. Okay, so it would be 0.33333333. So it would be 44.333. Okay, then we'd graph these and look where they intersect. Now, the problem is that right there is going to be tough to graph. This is where our buddy Desmos comes into play. Because we're just graphing and looking where they intersect, and with these more difficult equations, it's a really good idea to have some graphing, whether it's our graphing calculator we use, we type in our equations, or if it's this Desmos, which can help us visually quickly see what's going on. So, I'll graph both of them. Okay, so the red was high school B, orange high school A. So they meet at 14:21. What does that mean? It means on each van we can hold 14 students, and each bus 21 students. Okay, now the reason I use this Desmos here is not to cheat, but it's to make it easier for us, because we could have spent a lot of time trying to graph this guy, okay, and it wouldn't have been too fun. So being able to see it like this, because when we graph, that's the one downfall of graphing. So the question is could we solve this a different way? The answer is yes, but we won't learn that till later. So using this graph can help us get a more accurate, and that's why we have the technology to help us get more accurate. Now our graphing calculators can do the same thing. Okay, so let's take a look at this one. So once again, we've got 2 people. Okay, they're selling stuff. We want to find the cost of 1 package of tulip bulbs and the cost of crocus. So we'll call X tulips, the cost, right? And Y crocus, the cost. So we set our equation. Maria sold 11 tulips. So tulip is X. If we knew the cost of the tulips, we'd go 11 times that cost. We don't know the cost, so we'd put X. 5 package of the crocus. So 5 times the cost, which would be Y. Add them together, that should equal 131. Okay. Then we could change it to slope-intercept form. 5y equals negative 11x plus 131. Divided by 5, now we run into an issue, don't we? Y equals negative 11/5 x plus 131 over 5. Those are going to be decimals. Ugh, bleh. Don't like that. So we'll use our good old-fashioned Desmos to help us out here. But first, let's get our other one. So 8 tulips plus 4 packages on the times the cost of crocus should equal 100. So if we change this one, is this any easier to graph? 4y equals negative 8x plus 100. I think it would be. See, this one wouldn't be too bad to graph, because we'd have negative 2x plus 25. Not so bad. However, I'm still going to use Desmos just because it'll save us time on that more difficult equation. Because I'm not going to try to deal with decimals. They're very difficult to graph. Okay, even if I have graph paper. Really the only way it becomes easy is if you manipulate your graphs so that those decimals, those fractions, become a lot easier to deal with. Okay? So, got my graph. So here we see, purple was is that Crocus? Purple was Maria, and blue was Abhazra. So where do they meet? And that's the important part. They meet at 8, 9. So the x was 8, the y was 9. What does that mean according to our story? The cost of tulips, $8. The cost of crocus bulbs, $9. Okay? So once again, that website is called Desmos.com. It's an easy graphing calculator. The reason I like it, I can put in my equations in this format, in standard form, and it'll graph it. And it'll help me see those important pieces to my graph. Okay, it's a great way to check your guys' work. Please don't abuse it, but use it to help you with your work. Okay, one more of these guys. So Jimmy's school is selling tickets to a fall musical. On the first day of ticket sales, well, let's see. Look at the end. Find the price of a senior citizen and the price of a child. So senior, we'll call X. Child, we'll call Y. The price, right? So, first day. Sold 10 senior citizen tickets and 10 child tickets for a total of $180. Okay? The school took in $109 on the second day by selling 8 senior citizen tickets and 3 child tickets. Well, that should be Y, huh? Okay, so now how do we figure out the cost here? Okay, well, that first equation would be pretty easy, right? Minus 10x, we'd get 10y equals negative 10x plus 180, divide by 10, and we'd get y equals negative 1x plus 18. Pretty easy to graph that one, right? We like that one. What about the second one? Minus 8x, 3y equals negative 8x plus 109, divide by 3. And this one's not going to work out, is the y equals negative 8/3 x plus, that would go in 3 times, then you'd have 19, so 6. Yeah, that's not easy to graph for us. Okay, that decimal. So once again, we jump to our handy dandy stuff. Okay, and we get, let's see, the blue was the first day, purple the second day. So where do they intersect? Where they're the same is 11 and 7. So 11 for X, 7 for Y. So that tells us senior citizen tickets cost $11, child tickets cost 7. Okay. Now, on those story problems, using technology can be very helpful. Okay. There's other ways to do this besides graphing, and we'll talk about those later. But let's just do some practice on graphing. And now we've got some easier ones that we can actually graph as we go about doing this. Okay? So, it may take me a while. We've got quite a few problems, but this will be good practice. My suggestion, try to do these on your own first, then watch the video. Or watch the video a couple times, or not a couple times, a couple problems for each type. So, slope-intercept, we like that. Easy to graph, right? Y-intercept of 3. Slope of 2, make it a fraction over 1. Positive, so up and to the right, or down and to the left, will give us that. The 2 is the top, so that tells us up or down. So up 2 to the right 1, or down 2 to the left 1. Because that bottom number tells us to go right or left, depending on which direction we start going up or down. There's our first equation. Graph the second one. Negative 2, negative 1/2. So we're going down and to the right, down 1 to the right 2, because the top number always tells us up or down. Or I can go the opposite way, up and to the left. So we go up 1 to the left 2. We can see right there where these guys intersect. And when we're just graphing like this without the story problem, without the context, that point of negative 2, negative 1, that's what we're looking for. Okay, positive 3, negative x means negative 1 over 1. So I go down 1 to the right 1. Or we go the opposite, up 1 to the left 1. There's my first equation. Start at negative 2 here. That's our y-intercept. Always start on the y-axis, never the x. 3 over 2, it's positive, so up and to the right. So up 3, to the right 2. I can see exactly. Honestly, I could have stopped right there. I know exactly where they intersect, and that's the whole point. Okay, so the x value of 2, y value of 1. We always put our answers in that point form. Okay, always put our answers in that point form. Now, number 8. Okay, negative 4, down 4. Slope is 2 over 1. Up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Okay, there's our line. Plus 3, up 3, same slope, 2 over 1. Now, if it's got the same slope, what is that doing? Are these two ever going to touch? No. Whenever you have the same slope with different y-intercepts, they're not going to touch. Okay? They are not going to touch. They're parallel, and so the whole point is finding where they intersect. So here we have what we call no solution. Okay? Alright, so let's jump on another one. Negative 3, start at negative 3. Slope of negative 2 over 3, so down and to the right. Down 2 because it's the top number. To the right 3 because it's the bottom number. Or the opposite, up and to the left. But we still go up 2 to the left 3. The bottom number is always going to be our horizontal. The top is always our vertical change. Okay, positive 2, up to 2 for our y-intercept. X is just 1x, so we make it 1 over 1, up 1 to the right 1, or the exact opposite, down 1 to the left 1. And you should hopefully notice that whenever I have a positive slope, it's always going up in this direction. Whenever I have a negative, it's always going down in that direction. That should help guide you. But we find out where they intersect. Negative 3, negative 1. There's our answer. So sometimes we can have no solution like this. Same slopes, different y-intercepts. Many times we have just one answer, that x and that y value where they're the same, where they intersect. And sometimes we have a third answer. So let's graph this one down to negative 5. 3x means 3 over 1. So up 3 to the right 1. Or down 3 to the left 1. There's my graph. Now this one is in that standard form. We don't like standard form. Two ways I can graph it. I can use the x and y intercept method, but you guys seem to like the solving for making it slope intercept form. So that's what we're going to do. So I'd add 6x, right, to get the, because we want to get the y by itself. So I'd get 2y equals 6x minus 10, divide by 2. And we get y equals 6 over 2 is 3x, negative 10 over 2 is negative 5. Y-intercept is negative 5, slope of up 3 to the right 1. What do we notice? We've got the same exact equations. So they overlap. So where do they intersect? Everywhere. Okay, this is what we call infinite, or sometimes you'll hear it said many solutions. This is our third type of answer. So you're either going to have no solution, same slope, different y-intercept, a point when everything's different, or the same when the two equations end up being the same thing. And we call it infinite solutions. Okay? Now let's take a look at 11. So as I change these, 3x, so we'd subtract 3x from both sides, right? So we get 2y equals negative 3x minus 6, divided by 2. We get y equals negative 3 halves 2x minus 3. Okay, and what if I do it to the other one? If we subtract 3x, we get 2y equals negative 3x minus 2, divided by 2. We get y equals negative 3 halves x minus 1. Now, look, same slope, different y-intercept. I know right now, no solution. I don't even have to graph it. And the trick here, I could have told you that right here, because I know that these x's are going to be divided by the coefficient of the y, and they're the same exact numbers, and these two numbers are different. If they were the same, they would have been this. But they're not. They're different, so that keys me into the fact. No solution. So do I even need to graph them? No, I don't. Okay, let's keep on trucking, because we got lots to look at. So, subtract x from both sides. We get negative y equals negative x minus 3. Divide by negative 1. Get y equals positive x plus 3. So up to 3, positive x is like 1 over 1. Up 1 to the right one, or the opposite, down and to the left. That maintains that positive slope. Okay, second one, y equals negative 1. Now there's no x here. When there's no x, you go to the y value of negative 1, and you draw a horizontal line. So where do they meet? Right there at negative 4, negative 1. Okay, 13, now we've got two standards, so we just keep changing them to slope-intercept form. Negative 2y equals negative x plus 4. Divide by negative 2. That becomes 1, so we get y equals negative over negative is a positive. X over 2 is like 1/2 x. Minus, because 4 divided by negative 2 would give us negative 2. Down to negative 2. Positive 1, positive 2. Up 1 to the right 2, because 1, to the right 2. Because that 1, or down 1 to the left 2. 1's on the top, so that's the vertical movement. The 2 is on the bottom, so that's the horizontal movement. Okay, then we subtract 7x here. So I get negative 2y equals negative 7x minus 8. Divide by negative 2. That becomes 1 and positive. That becomes positive 7/2 x. That becomes positive 8 divided by 2, which is 4. So up to 4. Now, we normally go up and to the right, but it's a little too far, so we'll go down 7. To the left 2. I see exactly where they intersect. Right there. So I get negative 2, negative 3 for my answer. Alright. So we do the same exact thing. Now, yeah. So subtract 5x, sorry, just thinking. 3y equals negative 5x minus 6. Divide by negative 3. Y equals negative 5/3 x. And I know I'm doing this quick, but I'm running out of time. Minus 2. So down to negative 2. Down 5, where I kind of run out of space going down, so let's go up. 1, 2, 3, 4, 5. But because it's negative, I've got to go to the left 3, right, to make sure that I maintain that negative slope. So subtract x, negative 3y equals negative x minus 12, divide by negative 3. That becomes positive 1, that becomes positive 1/3 x, and positive 4. So up to 4, up 1 to the right 3, or down 1 to the left 3. Boom. See where our answer is, and we collect it. Negative 3, positive 3. Now, on number 15, I'm going to show you guys the other way we can graph, okay, a standard form, and that's finding the x and y intercept, because the x and y intercept are always going to be 0 and then the y value, or the x value 0. I can use my equation and plug in to find the x-intercept, plug in 0 for y, keep the x, and solve for x, because 3 times 0 is 0, 0 plus 7x is just 7x. We get x equals 3. So I go on the x-axis to 3. Then for my y-intercept, I keep the y and solve for x. So for those of you that don't like finding the slope-intercept form, this is the other way you can do it. Divide by 3, and we get y equals 7. So I go up to 7. Now I've got 2 points, so I can find the slope from those 2 points and then graph it that way, or I can just graph it. Okay, now I look at this, erase my, and I do the same process for my other equation. Okay, so for the x-intercept, make the y 0, because that y is always 0. Keep the x, that becomes 0, so I get 21x equals 63, divide by 21, and x equals 3. So I know exactly where they're going to intersect right here, right? The thing is, I've got to double check my y-intercept to make sure it's not the same line. So make x 0. This is only when you're graphing using the x and y-intercept. Usually only works with the standard form. The slope-intercept form is just really easy. So you don't have to use this way. You could have changed these both to slope-intercept form, and you would have found out that they would have been the same line. So we call that infinite solutions. But I just wanted to show you guys there's more than one way to graph these standard form equations. Alright, last two. So subtract 6x, not 4y, right? So we get 4y equals negative 6x plus 24. Divide by 4. We get y equals 6 over 4 would be negative 3/2 x. 24 over 4 would be plus 6. Notice, same slope, different y-intercepts. Key you into the fact that these are parallel, so there's no solution. So do not worry about dealing with them anymore. Okay? And the last problem here. Okay, so we'd add 2x to both sides, wouldn't we? Because it's minus 2x. So we get to get the x over, we add. So we get positive 2x minus 12, divide by 2, and we get y equals x minus 6. So down to negative 6, then up 1 over 1, because it's x. So when I say up 1 over 1, I meant up and to the right, or down and to the left. And we graph that last one, positive 6, negative 5, so down 5, to the right 1, to the right 1. I see where they, wow, horrible line there, but I see where they intersect, at 2, negative 4. That's my answer. So, there was a lot of practice with graphing. Hopefully you guys are getting that homework done and getting that practice in, so you guys know what you're doing.